Hello, kind peoples. How are we doing today? Where's everybody else? Spring break has not arrived, y'all. Y'all cannot let the minds wander just yet. It's almost time, but not just yet. Okay? Okay? All right, cool. Before we continue, I want to go back for just 1 second. I want to go back for just 1 second, and I want to remind you guys of the one key thing right here. When we are on the standard normal curve, the mean is 0 and the standard deviation is 1. When we are on the standard normal curve, our values are called our z values. Yes? Right? This is going to be very important for today. So I just want to take a step back just to remind us about this fact right here. All right. So the last time we were looking at converting from scores to z values. And then we learned of this very important value formula that the z is equals to the score minus the mean divided by the standard deviation. Right? This is a way of standardizing scores. And so if I have, for example, SATs and ACT scores, originally I can't compare them, yes? SAT, you can get up to 800, ACT, I can get up to 30, right? But if I subtract the mean and the standard deviation, both scores will now be on par because the mean for both scores will be 0 and the standard deviation for both scores will be 1. And then I will be able to compare scores from the two groups. All right? Questions there? All right. So I hit the play button. So they had so we're talking about women's heights. A woman's height was 67 inches. And what happens is they want us to calculate the z-score for that woman's height. The average height is 64 and the standard deviation is 3. And so if you plug this in, 67 minus 64 divided by 3 gives me 1. And so we say that this person is 1 standard deviation above the mean. Her height is 1 standard deviation above the mean. All right? And that should kind of make sense. The standard deviation is 3, right? And 64 plus 3 is 67. She's 1 standard deviation above the mean. Questions there? I showed you guys a second way to get to the same answer of 1. And the way you do that right here is you do this in salt. And let me reintroduce salt right here. When you open salt right here, you open on this page. What you want to do is go to the distribution calculators. For the previous test, we switched over to the binomial distribution. But for us today, we'll be using the normal distribution. Yes? You put in the mean of 64 and the standard deviation of 3. I have selected a left tail test, although in this example, it's not going to really matter. And then I put the lady's score right here of 67. Yes? Once I've done this right here, down here, you see it calculated the z-score for me. Questions there? Also, if I was to go over here, again, this is not as precise because let's say the z-score is 0.8. You can't really see that well right here. But you can see right here the mean of 64 has a z-score of 0. 67 has a z-score of 1. 70 has a z-score of 2. Yes? When we're using the empirical rule, every standard deviation, it changes the size of the probabilities. Yes? If you're 1 standard deviation away, this right here is what percentage again? If you're 1 standard deviation away? 68%, right? If you're 2 standard deviations away, you are 95%. And if you're 3 standard deviations away, you are 99.7, almost all. Yes? Yes? Remember, you have to remember those 3 numbers. You will not be given to them on the test. Question there. All right. And so that gave us, in this particular example, a different way to get the z-score because 67 has a z-score of 1. But like I said, this is more inexact. If, for example, the height was 66 inches, then you came really, really off right here. So if I put in a height of 66 instead, like so, you can see the z-score is 0.667. It's kind of hard to read 0.667 over here. You can just tell it's between 0 and 1. That's all you can tell. Questions there? All right, cool. So we are talking to our good friend. And we did the comparing of the two SAT scores. What we had to do was convert both of them to z-scores. Once we converted them both to z-scores, we could clearly see that the student who took the SAT did more standard deviations above the mean, so they had the better score. All right, so I think that's where we stopped the last time. All right, mean length of a one-year flounder in millimeters. The mean length of a one-year-old flounder in millimeters is 119 with a standard deviation of 21. The mean length of a two-year-old flounder is 169 with a standard deviation of 33. The distribution of flounders both are approximately normal. Again, this is one way of saying this right here. Joe caught a one-year flounder whose length had a z-score of 1.3. How long was the fish? So in this example, instead of giving us the length or the student score, they're giving us the z-score and they want us to work backwards. Yes? And so there are actually two ways to work it out. One is you can have the formula, so z is equals to x minus mu over theta. Any algebra friends, any algebra people in the house? Any algebra people in the house? Any algebra people in the house? If you're an algebra inclined person, you simply plug in all the details and solve for the missing value. And so z is 1.3. X is unknown. The mean is a one-year-old founder, right? So the mean is 119. And the standard deviation is 21. And you just solve this equation for X. Yes? If you are not inclined algebra person, you can instead remember the formula. So if I unwind this equation, theta is going to get multiplied by z, correct? And so therefore, X is going to be equals to mu plus theta. Then I put the z in front, z theta. You can use this formula instead. Obviously, they're both are going to give you the same answer. Questions there? I've just unwind the equation, gets the answer that we need. There's a third way to get the answer. And of course, that third way is salt. So in salt right here, I go back over here to salt. Again, notice I'm just leaving it as a left tail test. Excuse me. I'm going to put the mean in. The mean was 112, yes? 122. I didn't forget already. 119. Standard deviation of 11. I was just off. So 119. Standard deviation of 21. And then what I'm going to do is I am going to plug in the z-score. The z-score was 1.3. 1.3. And then if I go up to the score value, this right here, 146.3, that's going to be the actual length of the fish. Questions there? Since the two boxes are tied together, the X and the Z-score box right here, once I change one, the other will change. If I change the Z-score to 0, 1, for example, you can see right here the score changed as well. Questions there? So since the two boxes are tied together, if I change one, it will automatically change the other. So if I plug in my 1.3, it'll automatically give me the correct Z-score. Oh, I didn't reset the page. Questions? Let me go back and then let's work this thing out. So Z-score up here, right here, they're doing the algebraic way. And so what happens right here is you multiply by 21, and then you add 119. That's the formula I just gave you. And that gives us the same answer we just got a while ago, 146.3. Questions there? All right. If they ask a second question right here, Cherry caught a 2-year-old flounder whose length has a z-score of negative 0.6. How long is that fish? Go ahead and type the information into salt and see if you can get the answer for how long the second fish was. Notice that it is a 2-year-old fish that they're talking about, not a 1-year-old fish. Go ahead and see if you can plug the numbers into salt so that we can get the answer, and then we'll work it out the algebraic way in a second. You know, we add just a little bit of salt. It's great. Are you glad you guys get the salt? Are we ready for the answer? Everyone guys having a chance to try? Anyone has a question? All right. So let's go ahead and get the answer and start, and then actually let's put this answer up first. Let's see if we all got the same answer. So again, we're using this formula right here. It is the standard deviation multiplied by the z value, and then we're adding the mean. Of course, they're not going to use the old numbers of 119 and 21. Instead, they're going to give us 169 and 33 because it's a 2-year-old flounder. And then plug it in and get an answer of 149.2 millimeters. Is that what we got from salt? All right, let me just make sure we all did the same thing. So in salt right here, you have to change the mean to 133, 169. 169 and standard deviation is 33. And then you go down to the z-score and you plug in a negative number, negative 0.6. That the point didn't work. 0.6. And then I come right here, I get the answer 149.2. Questions there? How my square is concerned? Cool. Cool. The key thing is I just want you to understand what salt is doing in the background to get this answer. This is what it's doing. All right, so the z-scores and the empirical rule right here. You guys remember the empirical rule, right? Again, remember it was just the empirical was defined within standard deviations, one standard deviation away from the mean. But a z-score is the standard deviations. And so you'll see one right here. If I'm within one standard deviation of the mean, 68%. Two standard deviations of the mean, 95%. Three standard deviations away from the mean, 99.7%. Question? All right, cool. All right. This is why this class used to be hard. You see this nonsense right here? When I took this class, people used to just gawk at this nonsense and have no idea what this table means. And then this was right when we're to the left, and then later on they're going to ask you for the right, and then later on they're going to ask you for in between. Later on, and afterwards, people just say, you know what? I'm just going to get an F on this test. I'm going to be okay. Yeah. But guess what? That's not our problem. Yes. Actually, literally, this section is scheduled to be taught over like 2.5 weeks. We're actually going to finish in like a week because it's so much easier with start. I do apologize. All right. So, when you see right here, normal CDF, right here, this just means the normal density function. And again, we're not going to be using even on the TI-83, it was hard. When I had to do it in a calculator, it was really hard to do. So let's skip all of that and let's get to the answer right here. Question. Find the area to the left of z equals 1.26. First, let me tell you why this question is important. When they're asking us to find the area, they're asking us to find a probability. Later on, they're going to switch the word area out with the word probability. All right? Because remember, for a cumulative density function, the area under the curve is a 1, correct? And so if I take any partial area, that gives me the percentage of the whole thing that's been covered. Yes? Now, the word left right here means less than. Yes? The word left right here means less than. Yeah? And so this is literally asking, find the probability of being less than 1 point, having a z-score of 1.26. Okay? In the fish question, find the probability of getting a fish that's less than, and we just need to switch this number out. I think the z-score for this was like 147 millimeters. Find the probability of getting a fish that's less than 142 millimeters, right? That's all they're asking us to do. Questions there. So this is why this question is important. Now, watch carefully how many pages they have to go through to help you understand the answer to this question. That's one, that's two, that's three, that's literally 3 pages to get to the answer. Look, they're still asking, no, my bad, 4, 5 pages to get you to answer this question, right? But all you have to do is simply go into SALT, set the mean to 0, and the standard deviation to 1. Why am I setting the mean to 0 and the standard deviation to 1? Because it's a standard normal distribution. Once they say z-score, they're telling you use 0 and 1. Yes? I hit left because they want to the left of the curve. Yes? And to reinforce that, if you look right here, you see the less than, right? To the left means less than. Yes? And then all you have to type in here is 1.26. 1.26. Ah, I missed. 1.26. And this is your answer right here. Questions there? To further help you understand your answer, over here, they have the answer shaded for you. So 1.26 right here, you see this line coming down? This line comes down at exactly 1.26. I want to the left of that area. And so this area is shaded. Questions there? The entire area under the curve is 1. And so if I am not shading the entire curve, the answer is going to be less than 1, yes? But 0 is exactly halfway, yes? Right? So therefore, this answer has to be somewhere between 0 and 1. Yeah? So answer 0 and 0.5 and 1, sorry, because 50%, half of it is down at 50%. Yeah? And so that where therefore the answer of 89.62, rounding to 4 decimal places, this is going to be our answer right here. Questions there? And so if I come over here into our good friend SALT, after 5 hours of typing numbers away, you get the same answer, 80.8962 or 89.62%. Questions there?
So when you say C equals, well, can you go back to the salt?
Uh-huh.
Okay, never mind. Wait.
Yes, because it's a 0, 1, the two values are going to be the same. The z-score and the score they have are going to be the same because it's standard normal 1. If, for example, remember I was doing the fish, and then the mean was 119 and standard deviation was 21, then the two scores will be different. Anybody else? All right, so they say, this is so hard. Let's try and make it harder. And then they ask, what happens if I want the area to the right of z, negative 0.58? See if you can get this unsolved for me, please. You can get this answer unsolved for me, please. This time we want the right. This time we want the right. You guys finished already? That's technically means we're done in this section already. I'm going to stretch this out a little bit longer. We got an answer? Everybody's got an answer? So I just go to SALT. And my SALT is already at 0, 1, so I have no problems right here. I switch over to a right-tailed test, yes? And I plug in up here, what was it, 0.68, 58, 0.58, and then this is my answer right here in the box, 0.719. Questions there? Again, they shaded more than half, right? Because the mean right here, this is halfway. If I start shading from here and I shade it, my answer is going to be greater than 0.5. Yes? The only reason I'm pointing this out is back in the day when we had to do it the hard way, you have to be aware of these nuances because sometimes you work this out and you get an answer of 28%. And then clearly 28% can't be right. Yes? That's just ingrained in me to just think about it from a whole holistic picture. Look at what was shaded and then look at your answer. The two things should line up. Yes? Right? Questions? Okay. Next one. I gotta skip through all of these slides. Skip. So again, using the table, again, we got you see, in the table, they had the wrong answer. If you looked it up in the table, you'd get the wrong answer. And then you have to use your common sense. This is not the right answer. What am I supposed to do here? And again, you don't have to worry about any of this right here. Salt takes care of everything for you. And so they finally got the same answer that we had. All right. Questions there? Questions there? Hello, you missed the whole class. We're just about to. I gotta stay, but I'm contractually obligated to stay. But literally, we're finished the section. Yeah, I know. And no, don't worry. I gotta take my time. We'll go back over it. That's fine. And again, this thing takes forever to do the other way. And so try this one right here. Find the area between negative 1.45 and a 0.42 using salt. You guys experience already? Well, we can talk about good times. What you guys do to have a good time? Sleep. What else? What else? You guys, these days, I'm doing a whole bunch of research now. I'm looking at drug discovery. I'm looking at trying to use artificial intelligence to help students learn better. I'm just having a good time. Yeah, no, the negative 1.5 goes in the lower box and the 0.42 goes into the upper box. Yes? If you put the other way, it'll give you an error. It's so nice. So again, so I just go over here into salt. So again, everyone's with me, we're in salt. Make sure you have selected the normal distribution. Somebody remind me again, why do I have 0 and 1 right here? Because the z-score is a standard normal score. Yes, it's a z-score right here, so that's why it's 0 and 1. Later on, when we move to the next section, we'll give you the mean for the fish and the standard deviation for the fish. But standard normal, 0 and 1. Yes? And then we go over here and we select between. The question literally said between. Yes? And then we simply putting out two numbers, which I have already forgotten. It was negative 1.45 and then positive 0.42. Like so. And then this right here is your answer. The probability that we're between z equals negative 1.45 and 0.42, that probability is 0.58923. Questions there? You can verify this if you go over here to the picture right here. Again, see right here, negative 0.45, right? This is approximately negative 0. Well, it is negative 0.45. And then over here, this is 0.42 right here. And then that's the area that they shaded inside the curve. Questions there? By the way, when you switch to a between, like so. I changed it. But when you switch the between, it gives you the z-scores as well. Gives you two z-scores, not one, because you have two numbers. It just being nice to you. And finally, I don't have a question on this right here, but there's also a both tails. When we're using both tails, we're shading on the outsides of the curve. So find the probability, for example, that the size of the fish is either less than 140 millimeters or greater than 160 millimeters, right? And then you just use the both tails to shade the outsides. And again, the inequalities will help you out. Less than and then greater than. So that's the outsides that were shaded. Questions there? Again, like I said, they literally had to spend like 5 hours going through all of these things right here to come down to the same answer. And notice right here that for every single one, left, right, between, and later on both tails, you have to do an entirely different operation to get to the answer. Again, that's part of the reason why this was so confusing, is that you have to memorize different steps for each problem. But you don't have that problem no more. Literally, salt is exactly the same things every time. Enter the mean standard deviation, select the right point, left, right, between, and then put the two numbers in, and then that's it. All right. Cool. All right, so like I said, I'm finished. We're moving on to 6.3. Well, actually, no, I just moving on to the next slide, which is going to be, yeah, it is 6.3. All right, so back to the top. So the first thing they wanted you guys to just remind you of the empirical rule, right? The only reason why they're reminding you of the empirical rule in the section is sometimes you come across questions that say use the empirical rule. When you come across those questions, you cannot use salt. Guess what? Salt gives you the answer to too accurately. This is the answer right here to two decimal places. Salt gives the answer up to 6 decimal places. All right. And because of that, this leads to errors. The empirical rule answers are always wrong. They're always off, but they can tell if you use salt or not. So, because the empirical rule, sometimes the answers round differently because it's off by so much. And so they just want to keep in mind that if it says use the empirical rule, you must use the empirical rule. Okay? You can certainly use a little salt to check if the answer is close. But all right. In a large sample of customers accounts billing. All right, so let me just set the stage right here. In this section, we're no longer going to be using 0 and 1 power mean and standard deviation. That's the only change for this section. So we're going to do what's called the real world examples. This is supposed to interest you guys, right? We're going to be using real world examples, but we're not going to have a mean of 0 and mean of 1. We're going to have real means and real standard deviations. And so they're restarting the whole process. They're going to teach us the empirical rule first, and then teach us back how to use salt again to get the answers to these questions. All right? So in a large sample of customer accounts, a utility company determined that the average number of days between when a bill is sent out and payment is made is 39 days with a standard deviation of 4 days. Assume the data is approximately bell-shaped, i.e. normal. Estimate the range of days in which almost all the data will be found. The key part right here is almost all. That's what's telling us to use the empirical rule for this question. And if you guys remember, for the empirical rule, we're just using a number line, yes? So I will draw my number line right here. What comes at the center of my number line? My number line. What's my mean? 39 days. Yes? Now what's my standard deviation? 4. So one standard deviation, that's going to be 43, yes? Two standard deviations, that's going to be 47. 3 standard deviations above the mean, that's going to be 51. Is that okay? I'm just adding the standard deviation each time. Yeah, standard deviation is going the other way. It's going to be, so one standard deviation now is going to be 30, 35. Going down 2 standard deviations is going to be, and then going down 3 standard deviations is going to be 27. Yes? Now, almost all is 3 standard deviations away from the mean, correct? So what are the two numbers that I need right here to plug into the box to get my answer? 27 and 51. Questions there? Almost all is 3 standard deviations away from the mean. Questions? Huh? So they go ahead, they draw their triangle right here, 39, almost all, 99.7, 3 standard deviations away from the mean. They just calculated them directly, right? I had to subtract 4 3 times, yes? So they just skipped to the answer 27. And then I had to add 4 3 times going up. So they just skipped to the answer 51. Yes? And so those are our two answers. Questions there? All right, cool. A vending machine automatically pours out soft drinks into cups. The amount of soft drink dispensed into a cup is normally distributed with a mean of 7.4 and a standard deviation of 0.3. Estimate the probability that the machine will overflow an 8-ounce cup. This is where these things get a little bit tricky. What is this question actually asking us to do? Let me write it out and you tell me if you agree with me. This question is asking me to find the probability that the amount of soft drink dispensed is greater than 8. Yes or no? Do you agree with me that this is what this question is asking? It doesn't say it out. It doesn't say directly, but it says overflow. To overflow means I have to put more than 8 fluid ounces into that cup. And so that's what it's asking me. It's asking what's the probability of me putting more than 8 fluid ounces into that cup. Does that make sense? Questions? Comments? Queries? Concerns? All right. So now that I have this right here, I am using the empirical rules. I got to draw my number line. What comes at the center of my number line? 7.4. I am going to be adding 1 standard deviation. So that's going to be, I'm going to add 2 standard deviations. That's going to be 8. 3 standard deviations, just to be sure, going to be 8.3. Subtracting 1 standard deviation is going to be 7.1. By the way, guys, you know you can use calculators for these, right? Subtracting another standard deviation is going to be 6.8. And then subtracting one more time is going to be 6.5. -3 standard deviations. So the key thing right here, let me draw the curve in for us. Wow, I'm great, is that they want this area right here. They want this area right here above this line. Have I lost anybody? Now, it turns out that you can calculate the area above this line, but it's a little bit tricky because we have not actually been given this area yet. When we were given the empirical rule, we weren't actually given this area right here. So let me give you a hint. When I am within 2 standard deviations of the mean, I cover 95% of the data. Let me see if that hint is enough for you to figure out the size of this area. What percentage is this area right here? This is what we call a math problem. Let's see if you guys can figure it out. 1%, 1.5. It takes a while to get the answer. You'll have to write. 2.5. Shaking your head for which one? 2.5. Change your mind to 2.5. Anybody else? 2.5. Anybody else? So was my hint enough to get to the answer? So if the area I have shaded in the middle is 95%, how much is remaining? 5%, correct? That 5% has to be split into two pieces. Yes? So if this is 95%, then this side is going to be 5% divided by 2. And then this side is going to be 5% divided by 2. Yes? And so then this piece right here has to be 2.5%. Question? Comments, queries, concerns? Now let me just show you this right here, is that if I did this in salt, oh, it's not salt. If I did this in salt right here, what does it mean? 7.3 or 7.4? 7.4, and the standard deviation was 0.3. Yes? I'm going to choose the right tail. Somebody remind me, why am I choosing a right tail? Okay, it was greater than, yes? And then I'm going to plug in 8 right here. Why am I plugging 8 right here? Because, yes, the question is, when will it overflow? When will it be greater than 8 fluid ounces in there, yeah? Look at the probability that it's giving me right here. Is this 2.5? Is it even close to 2.5? No. And the reason is because the empirical rule, they rounded the numbers a lot, right? It's not 68%. It's actually, I can show you the exact value. So if I hit between and I plug in 68%, once there's two standard deviations, right? So I put in -2. Oh, I gotta change the 0 and the 1. Where's my number? 28. If I plug in, where's the negative sign? There you go. -2. And in the other box, if I put in 2 right here, and I put this as 0, and I put this as 1. Ah, it then reset my numbers here. Where the negative sign go? There it is. -2 and 2, right? See, it does not give me an answer of 95%, right? It's 95.45. So 95 isn't wrong, right? But it's rounding. And when I switch it over and I'm using this salt right here, if I divide this by 2, I get a number that's slightly different from the 2.5 that we got. All right? And that's why when the question says empirical rule, you have to use those numbers, 68, 95, and 99.7. Okay? Questions there? Salt isn't wrong. It's just there's a rounding error. All right, and so they did this for us right here, 7.4, 8 is up there. Overflow, we need the right tail of 8. So that's the side they're going to shade. It's 2 standard deviations above. The middle piece is 95%. And so what happens is they take the 5% and they divide by 2, and they get the same 2.5% that we got. Questions there? Questions there? So the answer was 0.02245 or something like that. Different answers. All right, so all right, we've already talked about all of this right here. There are different ways they can ask us questions. They can ask us between. When they talk about between, they're talking about us sharing the area in between 2 points. Again, we don't need to know all of this right here. They can ask us to the left or right, or the tails, right? Shade the area on the left, shade the area on the right. They can ask us for a left tail test where they're shading the area only on the left side. Again, keywords like less than, right? And then they can ask us for areas on the right side. Again, saying greater than or more than, right? Those are the 4 ways we can answer. Those are the 4 buttons that we have in SOLVE. Questions there? Yeah, cool. Whew. So 6.3 areas under any normal curve. So in other words, we're no longer going to be using the standard normal curve. We're going to be using a regular distribution. The mean is no longer 0. right? That's the key thing right here. We're switching over to new distributions, and no, we're not going to be using tables. Yeah, we're not going to do all of this right here. We're not doing any all of this right here. It's yeah, we're not doing any of this. So a study reported that the length of pregnancy from conception to birth is approximately normally distributed with a mean of 272 days and a standard deviation of 9 days. What proportion? When you see the word proportion, it's also asking what's the probability. The two words are interchangeable, okay? Because it's out of 100%. So if I take a proportion out of 100%, I'm still giving you a probability. Yes? What probability of pregnancies lasts longer than 280 days? Questions. Is this a right tail test? Is this a left tail question, or is it in between question? It is, I'm shading to the right because they say it lasts longer than 120 days. Yes? Right? Notice it's not going to say use the greater than sign, please. Right? They're going to put it in English. Right? And so all I have to do is go and solve, put in the mean, standard deviation, and away we go. Somebody memorize the mean for me, please. And standard deviation is 9 days. All right. So I put a mean of 272. That what it was, right? And a standard deviation of 9. And I just select a right tail, and then we are in business. Questions there? It says, when is it greater than 280 days? Yeah. And again, if you zoom in right here, you see the greater than sign right here? It's they're giving you hints to remind you, hey, you are going along the right track. Yes? And the answer is 0.187. 18.7% of pregnancies go beyond 280 days. Questions there? All right, cool. Again, we don't have to standardize. We don't need to find the z-scores. We don't need to go looking them up in the table. We don't need to do any of this stuff right here. And they got the same answer as that. 18.7. Questions there? Again, see how they have this lovely, what happened there? See how they have this lovely picture right here, how they shaded above 280? Salt has that same picture for you over here. So you see right here, 280, a shade above 280. Questions there? All right, so I'm well ahead of schedule. So I should start right now. Technically, you can actually do all of almost all of 6.3 already. There's only one concept that's left to cover, but literally the next two examples, one of them is simply going to be less than, and then the other one is going to be an in between. That's like half the lesson. But again, we can already all do all of those already. They just changing the language so you can see an example of each. The reason they had to do this back in the day, because for each and every one, you had to do something totally different to get to the answer. Yes? But now it's just streamlined to do the same thing every time to get to the answer. So, all right. Let me take attendance, and then I can send you guys on your way.